Good morning, everybody. This Calculus 3, we're going to look at homework assignment 13, chapter 13, section 3. All right. So these are only 6 questions, but they have a lot of steps involved. So the first one, find the curve's unit tangent vector. Also find the length of the indicated portion of the curve from 0 to pi. All right, so let's look at question number 1. R of t equals 3 cosine t I, 3 sine t j, plus t radical 7k. Again, t is an element, the domain is from 0 to pi. So we're asked to find the unit tangent. Yeah, unit tangent vector, which is that. So we have to find v and then the magnitude of v. So to find v, we take the derivative of r. Derivative of cosine is negative sine t. Derivative of sine is cosine t. And derivative of t is just a constant. So it's radical 7k. Now we got to find the magnitude of v, which is negative 3 sine t squared. We just take each component separately and square them. I'm going to take the square root of it. So negative 3 squared is 9 sine squared t. Positive 3 squared is 9 cosine squared t. Square root of 7 squared is just 7. These two we can factor out of 9. We have sine squared t plus cosine squared t plus 7. Sine squared plus cosine squared is 1. So 9 plus 7 is 16, which is 4. So that's the magnitude. All right, so now we have to find this ratio. So it's negative 3 over 4 sine t plus 3 over 4 cosine t j plus radical 7 over 4k. These are the first answers. Those are our components. The components of number 1 are negative 3 over 4 sine t, 3 over 4 cosine t, and radical 7 over 4k. All right, now we got to find the length of the curve. Length of the curve L. And this is the derivative of t squared plus the derivative of y squared plus the derivative of c squared dt. Yeah. Okay, let's rewrite what we had. R of t originally was 3 cosine t of I, 3 sine of t I, plus t radical 7k. B of t is negative 3 sine t of I, 3 cosine t of j, plus radical 7k. So remember L. All right, so in our case, our integral is going from 0 to pi. And actually, we already calculated all this. So it equals 4. The integral of 4 is 4t from 0 to pi. 4 pi minus 4 times 0. The answer is 4 pi. So that's the length. 4 pi. Okay, question number 2. Get another sheet there. Question number 2. Find the curve's unit tangent vector of, so it's exactly the same thing we just did. All right, so we got to, let's see what we start off with. 6t cubed I plus 2t cubed j plus 3t cubed k. T is in the closed domain. So the first thing we gotta do is figure out v. Remember, v is the first derivative. So this becomes 18t squared I, 6t squared j, 9t squared k. I gotta find the magnitude, which is 18t squared squared, 6t squared squared, 9t squared squared. So 18 squared is 324. T squared squared is multiply the exponents. 6 squared is 36. T to the fourth. 9 squared is 81. T to the fourth. Squared squared multiplied. So they all have T4s, so we just have to add the coefficients. Which is equal to, see, this is 360 plus 81. Square root of 441. 20 has to end in 1. 2 times 2 is 4. So, and square root of t to the 4th is t squared. So that's my magnitude. So to find the unit vector, I take my v, which is 18 t squared, divided by 21 t squared I, 6 t squared over 21 t squared j, and 9 t squared over 21 t squared k. Simplify here. 3 goes into 18 6 times. The t squares cancel. 3 goes into 21 7 times. 3 goes into 6 twice. The t squares cancel. 3 goes into 21 7 times. 3 goes into 9 3 times. 3 goes into 21 7 times, and t squares cancel. Right, so those are the components of my tangent vector. 6 over 7, 2 over 7, 3 over 7. Now the length, second part we have to find. So the length is equal to, so the length, we take this, because we're taking the length is the integral of the magnitude. And it's saying we're going to the bounds of 2 and 3, so from 2 to 3. 21 is a constant. 2 to 3. The integral of t squared is t cubed over 3 from 2 to 3. So it's 7 t cubed from 2 to 3. So that is 7 times 3 cubed minus 7 times 2 cubed. I should just factor out the 7s and just do 3 cubed minus 2 cubed, which is 3 cubed is 27 minus 8. 7 times 19. 63, so it's 133. So the length of the indicated portion is 133. All right, number 3, the last page. Number 3. Find the point of the curve. Write this stuff down. Find the point on the curve R 5 sine t, 5 cosine t, and 12t. Okay. Distance is 39 pi. Units along the curve from the point 0, 5, 0 in the direction of the increasing arc length. So we're just looking for the point. So the first thing we have to do, we have to find, what we have to find is t. From A to B, which is the magnitude of the vector. But here, remember, we can't use t, we have to use tau, because A is t sub 0 and B is t, because we're using t as a bound. All right, so what we have to do first is find the derivative of r, which is the derivative of sine is cosine, derivative of cosine is negative sine, and derivative of 12t is just 12. Now we have to find the magnitude. Five cosine t squared negative 5 sine t squared plus 12 squared. So distribute that, I get 25 cosine t, 25 sine t, because negative 5 squared is 25. 12 squared is 144. These are squared. Sine cosine are squared. We can factor out the 25 out of both of those. And one of the trig identities, cosine squared plus sine squared is a unit circle, that equals 1. So it's 25 plus 144, which is 169. The square root of 169 is 13. And that's the magnitude, or the length of the velocity vector. All right, so now we got to find the s. We have to do the integral. So s of t is equal from t sub 0 to t of this value, because remember we're taking s is the magnitude of input. So the magnitude is 13 tau, because we're using t as a bound. And we know that our initial t, we started from the origin 0, 0. So this one is 0 and goes to t. Integrating that, we get 13 tau from 0 to t. That equals 13t minus 13 times 0, which equals 13t. So we know that S equals 13t. Since all of our other functions are functions of t, solve for t. So t is equal to S over 13. Okay, so we're looking for our position, so we have to go to our position vector. Go to our position vector, R of t, which was 5 sine ti, 5 cosine tj, plus 12tk. What I want here is t is S over 13. So it's 5 sine S over 13 I, 5 cosine S over 13 J, plus 12 S over 13 K. We have to find that for each term. Put that up. Remember, our question said, so take away my initial conditions, our distance was 39 pi. So anywhere we see an S, we put a 39 pi. I cosine 39 over 13 J, (39 pi over 13). Okay. So S is 39 pi. What we're really doing, because remember at this point here, we have R of t, right? And since t equals S over 13, t is actually a function of S. So we're doing here, we're going R t of S, which goes from here to here. And since we said S, this is actually T of S is the distance. So that's what's happening here. Oops. Okay, so now let's simplify. (39 divided by 13 is 3. 39 divided by 13 is 3. (39) there. So now we evaluate. Sine of 3 pi. So it's our unit of circle. 1, 0, 0, 1, -1, 0, 0, -1. So at 3 pi, 1, 2, 3. Sine is the y is 0. So that's 0. At 3 pi, 1, 2, 3. It's -1, And 12 times 3 is 36 pi. But remember, we're looking for distances here, so we can't have any, our distances cannot be negative. So we have our R value of the curve is 39 units along the curve. At the point 0, -5, 36. Well, it said is 0. What was the initial conditions it gave us? 0, 5, pi, positive 5, and 0. So in the direction of increasing arc length is, we're looking for the point, R values, 0, -5, 36 pi. All right, so that's how you do number. So it's 0, -5, 36 pi. Okay, next question is number 4. Find the arc length perimeter along the curve from point where t equals 0 by evaluating the integral s equals the integral from 0 to t, magnitude v d tau, then find the length of the indicated portion of the curve. So everything we do in this chapter, in this section, deals with taking a derivative of r. E of t cosine t, E of t sine t of j, minus E of t k, from ln4, negative ln4 to 0. Oops, to 0. That's the bounds. So the arc length perimeter is S of t. So what we have to find first is the derivative of r. Now, since these are products, it's going to be pretty lengthy. So the way I do E of t cosine t, the derivative of E of t is E of t, derivative of cosine is negative sine. So the derivative of this is et cosine t plus the negative, which is minus e of t, e to t sine of t. That's your I component. Now let's switch these for sine. Derivative of sine is cosine. So we have e of t cosine t plus e of t sine, I'm sorry, cosine of t. That's j minus e of t k. So that's the derivative of each one. Now we got to find the magnitude of v of t. E of t cosine of t minus E of t sine of t I. No, that's not squared, it's just squared. E of t sine of t plus E of t cosine of t squared minus E of t squared. This is a minus b squared, which is the first term squared. E of t cosine t squared minus twice et cosine t times et sine t plus the second one squared, et sine t squared. Do the same thing here. We have the first term, et sine t squared plus twice et sine t, et cosine t plus the last one squared, and this et squared. And it's all under the radical. E2t cosine square t. Et is e squared t. Cosine t sine t. E2t sine squared t. E2t sine squared t plus 2 E2t sine t cosine t E2t cosine squared t minus E2t. The only thing it cancels are these. The rest are pluses for right now because we have this one here. So we have E2t cosine squared t plus E2t sine squared t, E2t sine squared t cosine squared t minus E2t. In the first one, group these. I could take out E2t cosine squared t plus sine squared t, E2t sine squared t plus cosine squared t minus E2t. Those equal 1. E2t plus E2t minus E2t. Those cancel. We have square root of E2t. The square root of something squared is simply ET. Whew. All right, so it's got to be plus. That doesn't cancel because we're adding all those. So it's going to be plus, and that's going to be in parentheses. Okay, yeah. So it's 3 E2t squared, which means this factors out. ET radical 3. That makes it better. So that's the magnitude of V. All right, so now we gotta take that. We have to take that and find S. So we're taking the integral from 0 to t of e to the power t radical e to the power tau t tau the integral of e to the tau is e tau from 0 to t e to the t minus e to the 0 et radical 3. This equals 1, so it's a radical 3. So that is our first part, the arc length S. So it's e to the t radical 3 minus radical 3. Okay, so now we're going to find the length of the indicated portion of the curve. From negative ln4 to 0. So the integral, okay, ln3 is a constant. Tau. So the integral of e to the t is e to the, no, I'm sorry, it should be tau. From negative ln4 to 0. So radical 3 e to the 0 minus e to the negative ln4. That equals 1. So we have radical 3 minus radical 3 over e to the ln4. E to the ln4 is 4. Get a common denominator. So 4 minus 1 is 3 radical 3 over 4. And that's the length. Okie doke, we're almost done. I got 2 more to do. Number 5. Find the arc length perimeter along the curve from the point where t equals 0 by evaluating the integral s from 0 to t, absolute value of t tau d tau. Then find the length of the indicated portion of the curve. Okay, that is exactly what we just did in the last one. So it's a lot more writing. equals 2 plus 3t I 3 plus 6tj 5 minus 2tk from -1 to 0. So the first thing you do is find our derivative. So derivative of this, that's 0. So it's 3i 6j and -2k. So the first thing we have to do is find the magnitude of this. Three squared plus 6 squared plus -2 squared. Nine plus 36 plus 4 equals 49, which is 7. All right, so once we found this, we got to take the integral of it. From 0 to t. All right, this finds us our s. So from 0 to t, that equals 7, equals 7 tau. From 0 to t, 7t minus 7 times 0 is 7t. That's the arc length, 7t. Now find the length of the indicated portion. Since our portion was from -1 to 0, seven times 0 minus 7 times -1. 0 plus 7 is 7. And that's the other one. All right. One more. Number 6. So to illustrate the length of a smooth space curve does not depend on the parameterization used to compute it. Calculate the length of one turn of the helix with the following parameters. Okay, so let's try it. So the first one, A, equals cosine 4ti sine 4tj. Okay, from 0 to pi over 2. We'll find the first derivative. Negative sine 4t. Derivative of the middle of the inside is 4, so it's -4ti. 4 cosine 4tj and 4. Okay. Now I'm going to find the magnitude. Cosine squared. So 16 sine squared 4t, 16 cosine squared 4t plus 16. Sine squared 4t plus cosine squared 4t plus 16. This equals 1. So 16 plus 16, square root of 32. 16 times 2 makes it 4 radical 2. Because square root of 16 times square root of 2. Okay, we have to take it now from 0 to pi over 2. The integral of the constant is the constant with a t, which equals 4 radical 2 times pi over 2 minus 4 radical 2 times 0. That's 0. The 2 and the 4 cancel, so we have 2 radical 2 pi, or 2 pi radical 2. That looks better. So that's the first one. 2 pi radical 2. The second one. R of t equals cosine t over 2 j, I don't need that, I, plus sine t over 2 j plus t over 2 k. This one's from 0 to 4 pi. So the derivative of cosine is negative sine. Derivative of t over 2 is 1/2 I. So cosine t over 2 j, and this is 1/2 k. So 2 squared 1/2 cosine t over 2 squared so that becomes 1 over 4. One over 4 plus 1 over 4. Factor out the 1 over 4, so we have sine squared t over 2 plus cosine squared t over 2 plus 1/4. So that equals 1. So we have 1/4 plus 1/4 equals 2/4, which is square root of 2/2. And for square root of 2/2, we have to take it further bounds. Integrate it from 0 to 4 pi of square root of 2/2. So it's a constant square root of 2/2t. Square root of t 4 pi minus square root of 2/2 times 0. That's 0. 4 pi square root of 2/2. Those cancel. So we get 2 pi radical 2. That's the second answer, so we get the same thing. And the last one. R of t equals cosine of ti minus sine of tj minus t of k. From -2 to 0. Negative sine ti, negative cosine tj minus k. Negative sine t squared cosine t squared 1 squared. It doesn't matter because if it's plus or minus either, when I square it, it becomes positive. So that's going to be sine squared t cosine squared t plus 1 squared. That equals 1. So 1 plus 1 square root of 2. From -2 pi to 0. So the integral of radical 2 is radical 2t. Radical 2 times 0 minus radical 2 times 2 pi. That's 0. So it's 2 pi radical 2. And that's the last one. All right. That does it for section 3. Hopefully, when we meet tomorrow, we could finish up the chapter.